Hello everyone, welcome to Jenkins Pipeline as Code, all you need to know from A to Z. Brought to you by Accelerated Skill Up. This course will help to speed up your learning on how to implement Pipeline as Code in Jenkins effectively, what its syntax is like, and what can be achieved using Pipeline as Code. This course is the outcome of my own personal struggles with understanding and implementing Pipeline as Code when I first started out, and I really hope that this course will help you shorten the learning curve by having everything you need in one course. I've spent a lot of time putting together what I think is one of the few courses around on Jenkins Pipeline as Code. I've designed this course for specifically two types of people: beginners who are just starting out on Jenkins Pipeline as Code, and intermediate people who want to have more knowledge on implementing Pipeline as Code in Jenkins. I have to state that this is not a setting up of Jenkins course, as it assumes that you already have some understanding of Jenkins and some programming knowledge. It would be even better if you already know Groovy, but that's not a strong requirement, as you would be able to follow what the Groovy code is doing, and I will explain more on Groovy during the course. There is a lot of content in this course, and I really believe that you will get a lot out from it. Please watch the preview videos, read the reviews, and I'll see you inside. In this lecture, I want to show you this interactive Excel spreadsheet that I've made, which I hope makes it easier for you to navigate the pipeline syntax. As you can see at the top left-hand corner, you have the column numbers, which you can click on to expand the columns. You can also click on the cross boxes to expand a particular section, and you can keep expanding to see what the options are for each section. We will be exploring further each section as we progress through the course. The text here is taken from the Jenkins Pipeline Syntax website, so credit goes to them. Please make special note that the decorative syntax always starts with the keyword pipeline, and scripted syntax starts with the keyword node. When you encounter problems and Google for answers, and you see that some answers in Stack Overflow, for example, starts with node, which is scripted syntax, you can't use that answer if you are using decorative syntax, unless you are using the script block inside decorative syntax, which we will cover later in the lectures. So please bear that in mind when you come across solutions in scripted syntax. Feel free to download and explore the spreadsheet, and I will see you in the next lesson where we will create a basic Hello World pipeline script. In this lesson, we will be creating a Hello World pipeline script based on what we see in the Excel spreadsheet. I just want to let you know that all of the source code for this course is available on GitHub. As you can see, agent and stages are required in a basic pipeline script, and within stage, you will need to define the steps section followed by whatever steps you want to put in. Let me first create a new Jenkins pipeline job. As you can see, we have set the agent to any, and we are echoing out Hello World using the echo step. We will be covering the agent section in a later chapter. Let's now save the job and run it. Looking at the console output, we can see the Hello World being printed out. And this concludes our Hello World example. In this lecture, we will be exploring the options available under Agents section. As you can see, we have the option of any, which informs Jenkins to run on any available agent. None, which informs Jenkins that there is no global agent, and if there are no agents specified at the stage level, then it runs on current Jenkins. Label, which tells Jenkins to run the script in a particular agent. We shall take a look at that next. For node, it is essentially the same as agent with a label, but also allows you to specify the location of the workspace. We will also explore that later. For any, we have already shown its usage in the Hello World example. Let's change it to none and see how it behaves. So as you can see, the pipeline script runs on the current Jenkins setup when we do not specify an agent under stage, which is optional. Next, let's see how label works. Let's go to Manage Jenkins and Manage Nodes. As you can see, we already have a slave set up right here. Take note of the name of the slave. It's called slave 1. We will need to use that for the label. Let's now go back to the Jenkins job. We will now change the script to point to agent label slave 1 and rerun the job. From the console output, you can see that the script ran on slave 1. Let's now change this to node and also add in a new custom workspace property. This custom workspace has already been created on the server side, on the slave server side. Let's rerun the job and see what happens. So it shows that it ran on slave 1 and it ran under the custom workspace. So let's go back to the Excel spreadsheet. For Docker and Dockerfile, we will skip that for now. We'll cover those in a later chapter. So this concludes our section on agent. In this lecture, we will be demonstrating how we can use a script step. The script step gives us the ability to program more complex flows beyond what the declarative syntax allows. It uses Groovy as the programming language. So if you want more power in your Jenkins script, you will need to learn some Groovy. There are courses in Groovy that can help you get up to speed on its syntax, but I'm sure that if you come from a programming background, you can follow what the Groovy code is doing in the Jenkins script in this course. Another thing that you might want to know is that you can also use declarative steps inside the script step. Let's see an example. So what this code is doing is using Groovy to specify a variable called name, and it has a simple if-else statement. Print line comes from Groovy as well, so you can use it to print out statements on Jenkins console. And the $sign brackets name is also Groovy syntax for referencing the name variable when printing out the string. After that, you can see that I'm calling the sleep step, which comes from the Workflow Basic Steps plugin, to sleep for 2 seconds, and I'm using the echo step to print out a string. Let's run the job and see how it behaves. So you get the hi Jeff, sleeping for 2 sec, and end of script lines. There you go. I hope you find this useful, and now let's move on to the next lecture. In this lecture, we will be looking at the error step and options directive, specifically the retry step in options, and also very briefly the script step. The script step provides us the ability to write custom code, custom groovy code, beyond what the decorative syntax allows us to do. We will explore further the script step in a later chapter. So what does the error step do? It indicates an error in the current stage and prints out an error message. In our example, we will be using it together with the options retry step to demonstrate how it works. So let's create a pipeline job. Before we save and run the job, let me just explain what is going on. So in this example, we have set the options under stage to retry 3 times if the stage fails. So under steps, we have printed a few echo statements and used the error step to indicate an error which will cause the stage to fail, and thus the script will retry the stage again. However, also note that the after error statement will not be printed out, as the script will bail out at the error step and retries the stage again. So let's save and run the job. So from the console output, you can see that the before error statement and error statements are printed out 3 times before the build eventually fails. Please also note that by setting the build result to failure within the stage, it does not make the script retry the stage again. Let's modify the script to see what happens. What the script does is to use the current build variable, which represents the current build, and set the result to failure. The current build variable is one of the many others made available by Jenkins to our pipeline script. We will cover these variables in a later chapter. Let's run the script again. So as you can see, the build has failed, but there's no retry. Now let's go ahead and move on to the next lecture. In this lecture, we take a look at the options timeout step. Steps in the options directive are invoked before entering the agent or checking any when conditions, which we will cover in another chapter. With this step, we can specify a waiting period before the steps section is executed. Let's take a look. Looking at the example script, we have set the timeout to be 1 second. Other valid values are nanoseconds, microseconds, and so forth. As you can see, we have used the sleep step from the Workflow Basic Steps plugin to make the script sleep for 2 seconds. This will cause the stage to time out. Let's save and run the job. The script waits for the timeout, echoing hello world, sleep for 2 seconds, and then it times out. I hope you find this useful. Now let's go ahead and move on to the next lecture. In this lecture, we will show you how to timestamp your console output. I will combine the demonstration for both stage level and pipeline level, as they are essentially the same. Let's create the pipeline job. As you can see, we have the timestamp option under the stage build, but we have none for the test stage. So the expectation is that we should be seeing the timestamp printed out before the echo lines for the build stage, but not for the test stage. Let's run the job. There you go. Now let's change it to be at the pipeline level. So as you can see, the timestamp step is specified at the pipeline level. So the expectation is that we should be able to see timestamp being printed out for every echo line. And there you go. We see the timestamp being printed out for the entire script. I hope this was helpful. Let's move on to the next lecture. In this lecture, we take a look at an issue that some students might face with the timestamps inside the options section as demonstrated in the previous lecture. Sometimes we might encounter an error, invalid option type timestamps, as described in this JIRA issue. I've given the link to this JIRA issue as a resource under this lecture. Now, when you get this error, one workaround is to use the timestamp block instead of using it inside the options block. Now let's create a job to see what that looks like. Now here we specify at the stage level a timestamps block, which must reside inside the steps block. Note that we are not using the options block at all. Let's save and run the job. Now, as you can see from the console output, we get the same result as the previous lecture, where we specified the timestamps as an option at the stage level. However, this alternative method will not work at the pipeline level, as you will get a syntax error. So going back to the configuration page, so this means that you can't put timestamps over here, or even at the pipeline level. You can't do that, right? You'll get a syntax error. Okay, so I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be demonstrating on how to use skip default checkout under stage and also under pipeline options as they work in similar ways. What this option does is to prevent the build from checking out source code from the repository automatically. Let's take a look at an example. So we will be making use of GitHub as a test repository, and as such we will need to create GitHub credentials in Jenkins. Now let's take a look at what is in the repository. So we have a Jenkins file which contains our pipeline declarative script and also a text file called normal.txt. So in here we have specified agent to be none at the pipeline level. This is important as we do not want the script to check out the code in the repository at the pipeline level. We want to control that at the stage level. So we have specified agent as any and the skip default checkout option at the stage level. This is just a normal text with a number in here, where we will be incrementing the number as we make changes to the Jenkins script so that we can see the effect of with and without the skip default checkout option. Now we create a multi-pipeline job. We will not be creating a normal pipeline job as we want to make use of the build configuration section, which will allow us to specify the location of the Jenkins file in the repository. This is the build configuration section, and this is where we specify the path of the Jenkins file. Let's save and run the job. As you can see, the multi-branch pipeline job is able to locate the Jenkins file under master branch. So as you can see from the console output, we have not been checking out any code from the repository. Let's go to the pipeline steps and check the workspace. And there's no workspace. It doesn't exist. So let's now uncomment out the skip default checkout. Let's now rebuild the job. So as you can see, the script checks out the file in the repository under the stage build and prints out hello world. Let's take a look at the workspace. And there you go, we have the Jenkins file and the normal.txt file. Let's now increment the number in the text field and enable skip default checkout. Let's see what happens. Let's now rebuild the job. Okay, so nothing's being checked out. Let's go to pipeline steps. And as you can see, the text is still 1. Let's now disable skip default checkout and recommit the Jenkins script. Let's now rebuild the job. Right, the push wasn't successful. Let's now run the job again. So as you can see, the code is being checked out, and let's check out the workspace. And the number has been updated. So let's now change the agent at the pipeline level to any, uncomment out skip default checkout, and update the number in normal.txt. Let's now rerun the job. So as you can see, when agent is set to any at pipeline level, skip default checkout option at stage level has no effect unless we specify options at the pipeline level, which I will demonstrate next. Recommitting the file. And now let's rebuild the job. So as you can see, no code is being checked out. I hope you find this useful, and now let's move on to the next lecture. In this lecture, we will be covering the environment directive at the pipeline and stage level. These are not global variables provided by Jenkins, but are environment variables specified in the script. We will also be covering the credentials method in the environment directive. So let's take a look at a simple example. So what we have here is we specified two environment variables, name1 and name2. And at the stage level, name3. And we print them out using the echo step from the Workflow Basic Steps plugin. We can see that the environment variables specified at the pipeline level are accessible throughout the script, and thus we can use them in the stage section. Let's run the job and see what happens. All three name variables are printed out. Let's now put in a new stage called test, and we try printing out the same variables. Let's save and run the job. So as you can see, name3 is only available in stage build, but not in stage test. So we encounter an error, but we have no issues printing out name1 and name2 in stage test. Let's now try a different scenario where we specify an environment variable at a stage level that has the same name as an environment variable at a pipeline level. We can now see that we have an additional name2 variable at the stage level. Let's see which one gets printed out. Let's run the job. We can see that Mike gets printed out instead of John. From here, we can tell that the environment variable at the stage level takes precedence over the one at pipeline level. It is also useful to know that the environment variables are also made available to scripts if you ever need to use them. Let's see an example. We have a shell step here from Workflow Durable Task Step plugin, which helps us to execute shell scripts or commands. We will be using print env to print out the environment variables. Let's run the job and see what happens. So let's search for name1 in the environment variables. Name2, and name3. So as you can see, all three name variables are all made available to the shell. So let's move on to the credentials method. This method here allows us to retrieve credentials previously created in Jenkins and referred to by its ID. Let's create some dummy credentials. We will now create credentials of type username and password. We will now add another credentials of secret text. Credentials of type secret files are handled in exactly the same manner as secret text, so we won't be showing that here. So with this example, we will try to access the credentials via their ID and printing them out. Note that for username and password credentials, we can access both the username and password using some username and password variable in the format of username : password. But if you want to access the username and password individually, you can use variables like some username password underscore USR and some username password PSW. Let's run the job and see how it behaves. We can see the print lines for some username password and some secret variables, but they all print out multiple asterisks. This is done by Jenkins to prevent revealing what the credentials are. I hope that this has been useful, and let's move on to the next lecture. In this lecture, we will be covering the when directive. The conditions in the when directive determines if the stage should be executed. It must contain at least one condition. If there are multiple conditions, all of the conditions must return true for the stage to execute. Let's take a look at the environment condition. With this example, we have a deploy to environment variable, and we have set the when condition to specify that the environment variable deploy to has to be or value production before the stage can be executed. Let's run the job. So as you can see, the echo statement is printing out deploying. So we know that the stage is indeed executed. So now let's change the value of deploy to something else and see if the stage runs. So as you can see, the stage was not executed. Now let's take a look at the equals condition. So we have an environment variable called someName that is assigned a value of Jeff, and the equals condition is expecting Jeff for the stage to execute. Let's run the job. So we can see that Jeff is being printed out, so the stage is indeed executed. So let's set the value of someName environment variable to something else and rerun the job. So let's set it to John, and we're expecting that it equals to evaluate false. Let's see what happens. So the equals condition is not fulfilled, thus the stage is not executed. Let's take a look at the not condition. we are reusing the previous example and nesting the equals condition inside the not condition. Let's change the name of some name to John. Let's run the job and see what happens. So the equals evaluation is returning false because we have John as the environment variable, and we are expecting the equals condition is expecting Jeff. But however, the not condition inverts the true value. So that's why the stage is executed. Let's now set the variable name, the environment variable name, to Jeff. So that we are expecting this equals condition to evaluate to true, and then that gets inverted by the not, and we're expecting that the stage is not executed. Let's see what happens. And yes, the build is skipped. So now let's take a look at the expression condition. The expression condition allows us to specify groovy expressions and evaluates them. Let's see an example. So here we have specified a groovy expression, an equals condition, for an environment variable called version. So it's expecting version to be 1.0 and this equals condition to be evaluated true. So let's save the job and see what happens. So we can see that the stage is executed. Now let's change the value of version to 2.0 and run the job. As expected, the stage does not execute. Now let's take a look at the all off condition. So what this condition does is basically requiring all conditions in it to evaluate to true. So we have two environment variables here, version and some name. So both need to evaluate to 1.0 and Jeff for the stage to execute. Let's see let's run the job and see what happens. And we can see that the stage is executed. So now let's change the value of version to 2.0 and rerun the job. We are expecting the stage to not be executed. And yes, the stage is skipped. Now let's take a look at the any off condition. So reusing the all off example, we have now replaced all off with any off. This condition requires that any of the conditions in it to return true for the stage to execute. Note that the version is set to 2.0 so that it evaluates to false, but we are still expecting the stage to execute as some name will evaluate to true. Let's save the job and run it. And yes, the stage executes. Now let's set the value of some name to John. So that this condition will evaluate to false and we're expecting the stage to not execute. Let's see what happens. And yes, the stage was not executed. I hope you have found this useful. Let's now move on to the next lecture. In this lecture, we continue to take a look at the other when conditions. Let's continue with the branch condition. So the branch condition specifies that the stage will execute only when the build is building a certain branch. In GitHub, we already have a repository for this example, where we have a single branch master and a single Jenkins file. This is the syntax for the branch condition inside the when directive. We see that we have two stages here, one for master and the other for dev. Each stage will execute depending on which branch is being worked on by the build job. Let's now create another dev branch. Let's now create the build job. We will be creating a multi-branch pipeline job. Choosing GitHub as a source. Let's save it. And we can see that the multi-branch pipeline job has detected the 2 branches and are building them. Let's see what the console prints out for master. So from the output, we can see that only the master stage is executed and the dev stage was skipped. Let's see the dev build job. It should be the opposite. Build master skipped, building dev. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the building tag and tag conditions. They are related to each other. The building tag condition only allows the stage to execute when we are building from a tag. The tag condition only allows the stage to execute when we are building from a specific tag or tag name that fits a particular pattern. Let's take a look at the building tag condition first. In GitHub, we already have a repository. That has a single branch master and a single Jenkins file. So in here, we have specified that the stage should only execute when we are building from a tag. Let's now create the build job. Selecting the multi-branch pipeline job. And we are selecting the GitHub as our source. Note that we have to add in a new behavior, discover tags, or the tags that we create will not be picked up by Jenkins. Let's save the job. So we can see that the master branch is picked up by Jenkins. Now let's tag the master branch. Okay, so we are now in the master branch. Let's tag it to be 1.0. And let's push it to GitHub. Okay, so when we go back to GitHub, under the release section, we can see that 1.0 is created. Okay, let's go back to Jenkins and scan the repository. We can see that it has picked up the 1.0 tag. And at the same time, you can see that there's a tags tab here. And we've got one tag right here. So let's do a build for the tag. So we can see that the stage was executed. Now let's do a build for master. So we can see that the stage was skipped because we're not building from a tag. Now let's modify the Jenkins file to use the tag condition. Let's replace the building tag with tag 2.0. And let's commit the file to the repository. Okay, so we're going to tag 2.0. And push it to GitHub. Okay, so now when we refresh this page, we see 2.0 and 1.0 tags, right? So they're both pointing to different commits. So what we're going to do now is to remove, delete tag 1.0, and we're going to move it, right, to point to the same commit as 2.0. Okay, so that's been deleted. And we're going to tag 1.0. Okay. And we're going to push it to GitHub. Okay, so now let's refresh the page. And you can see that both tag 1.0 and 2.0, they're both pointing to the same commit. Right, so that we're doing this so that when we build the 1.0 tag, it picks up the latest Jenkins file and not the one that was previously tagged 1.0. So now let's go back to Jenkins and do a scan of the repo again. Okay, so tag 2.0 was picked up, and you can see that the count for the tags tab has changed. So let's do a build for tag 1.0. Okay, so you can see that the stage was skipped because we are only building for tag 2.0. So let's go to tag 2.0 and do a build. And we can see that the stage was executed. Okay, so now let's modify the Jenkins file to use a pattern in the tag condition. So I'm going to replace tag 2.0 to tag release dash star. Right, so I'm going to commit this to the repository. and I'm going to tag this, right? Tag this as release to prod. And I'm going to be pushing it to GitHub. Okay, so let's take a look at the release page, and yep, we can see that release to prod has been uploaded to GitHub. Okay, so what we're going to do next is to move the tag 2.0. So first we're going to delete it from GitHub. And we're going to tag it again. And we are going to push it. Okay, so let's refresh GitHub's page, and tag 2.0 and tag release to prod should point to the same commit. Right? Okay. Now, let's go back to Jenkins. Scan the repository. Okay, so the release to prod tag was picked up, and the count has changed to 3. Okay, so let's do a build for 2.0. So the stage was skipped as expected. Now let's do a build for release to prod. And the stage was executed. Now, for the tag condition, there are other attributes that you might want to explore. I would encourage you to try them out, like comparator and the different values for comparator. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the changelog condition. The changelog condition only allows the stage to execute when the commit message for commit fulfills a certain regular expression. In GitHub, we already have a repository. For this example, where we have a single branch master, a single Jenkins file, and a normal.txt. So we have specified that the stage should only execute when the commit message contains a message that fits this regular expression. The normal.txt file contains some dummy text. It is there for us to modify so that we can commit changes to the repository. Let's now create a build job. Selecting a multi-branch pipeline job. Adding a GitHub source. We can see that the multi-branch pipeline job has detected the master branch. Let's see what the console prints out for master. It says warning empty changelog, probably because this is the first build. Let's now modify the normal.txt file. And as we commit, we will use a message that fulfills the changelog regular expression. Let's rerun the job. So from the console, we see that the commit message meets the regular expression and the stage gets executed. Let's now make some changes to normal.txt and put in a commit message that does not meet the regular expression. Rerunning the job. And from the console, you can see that the stage was skipped. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the change request condition. The change request condition only allows the stage to execute when it is a pull request. In GitHub, we already have a repository for this example, where we have a single branch master, a single Jenkins file, and a normal.txt. So we have specified that the stage should only execute when there's a pull request in the Jenkins file. In the normal.txt file, it just contains some dummy text. It is there for us to modify so that we can commit changes to the repository. Let's now create the build job. Selecting a multi-branch pipeline job. Selecting the GitHub source. And saving it. So we can see that the master branch is being detected. So now let's create a new dev branch. So going back to the DOS console, we do a git fetch. And changing the branch to dev. Okay, so now we are in the dev branch. So let's modify normal.txt. So let's change this to 2, saving it. Committing it to the dev branch. Okay, let's refresh the page. Okay, so the normal.txt file has been updated. Okay, so let's scan the repository now. We should see the dev branch. Okay, there you go. Now let's submit a pull request. Creating a new pull request. Let's go back to Jenkins and scan the repository. So we can see that there is a pull request. Going back to the main page again. Now we can see that there's a new pull request. Just ignore the number in PR8. It usually starts at 1, but I've done a few pull requests before, so just ignore that. So as you can see, the pull request has already been built. Let's take a look at the console. And you can see that the stage was executed. Now let's go back to GitHub. Merge the pull request. Confirming the merge. Scan the repository again. You can see that the dev branch has disappeared when there was a pull request. And let's go back again. And the dev branch appears again. So let's look at master. So when there was a PR merge, master was being built, but let's do a fresh build. Now let's take a look at the console. You can see that the stage was skipped, right? Because it's not a pull request. Now for the change request option, you can see that from the documentation, there are other parameters, other attributes that we can play around with, right? So let's take a look at a simple example using title. I would encourage you to try out the other options. So let's go back to DOS. So git branch. So we are at dev. Let's update the Jenkins file. Okay. So let's modify the change request to only execute the stage when the title is when-pr. Let's commit the new changes in. Okay, so the code has changed, has been submitted. Okay, so we're now going to put in a new pull request. Now take note that the title of the pull request is pipeline-change request. Right? So let's create a pull request here. Okay, let's go back to Jenkins and do a scan again of the repo. Okay, so we can see that a pull request was detected. Let's go back to the main page, and we've got a pull request 1 here, so PR9, and let's take a look at the console for PR9, and the stage was skipped, right? So that was expected. Let's merge the pull request. Confirming the merge. And let's do a scan of the repo again. Okay, so everything looks good. Dev branch shows up in Jenkins again. Now let's modify the normal.text. Okay, let's change the text here, saving it, committing the changes to dev branch again, and we are pushing it to the dev branch. Going back to GitHub, let's create a new pull request. Now take note that we are changing the title of the pull request to when-pr, right? Okay. Let's go back to Jenkins to scan the repository. One pull request was picked up. Let's go back in there. Let's look at the console of PR10. And as you can see, the stage was executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the change set condition. The change set condition only allows the stage to execute when the files that were committed has file names that meet a certain regular expression. In GitHub, we already have a repository for this example, where we have a single Jenkins file, a hello world.js, and a normal.txt file. So we have specified that the stage should only execute when the committed files have file names that fit this regular expression. So basically we are looking for just JavaScript files. Both the hello world.js and normal.txt files contain just dummy text. It is there for us to modify so that we can commit changes to the repository. Let's now create the build job. Selecting multi-branch pipeline. specifying the GitHub source. And saving the job. So we can see that the master branch has been detected. Let's see what the console prints out for the master branch. So it says here, warning, empty change set, probably because this is the first build. Let's now modify the hello world.js file. Saving it. Committing the changes to the repository. Running the job again. So now we see that the committed file names meet the regular expression and the stage gets executed. Let's now make some changes to normal.txt and commit it. Let's rerun the job again. And we can see that the stage gets skipped. Note also that you can also specify case sensitivity. Using this case sensitive field, and we have set it to true. So we're modifying the Jenkins file and changing the regular expression to look for file names that end with uppercase world and the extension to be JS. Let's also update the hello world.js file. Let's commit the files to repository. Let's now rerun the job. And from the console, you can see that the stage was skipped. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the before agent condition. By default, the before agent is set to false, which means that the script will execute the when directive on the remote agent, assuming there is one, regardless of whether the when directive is going to return true or not. However, when the before agent is set to true, the when directive will be evaluated first, and if the when directive returns true, only then will the agent be entered to execute the stage. Let's take a look at an example. So for this, we have set up the remote agent to be slave 1, which is viewable under Manage Jenkins, Manage Nodes. Slave 1 here. So let's create our Jenkins job. Take note that for this example, we have set the agent to none at the pipeline level. But at the stage level, we have set the agent to slave 1. Take note also that when directive will return false due to the fact that the deploy to environment variable is set to dev, but we are checking for production. So we are expecting that the script will execute on slave 1 as the before agent is set to false. Let's run the job and see the output. So as you can see, it's running on slave 1 and the stage was skipped. Now let's go back and change the before agent to true. Let's rerun the job. Now you can see that slave 1 agent was not called and the stage was skipped in master. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be covering the parallel block under stage section, which is useful if you want to run stages in parallel if there are no dependencies between them. We will also take a look at the fail fast option. Let's see a simple example. So here we have a stage that contains a parallel block that also contains other stages, indicating that all these stages are to be run in parallel. Okay, so the fail fast keyword being set to true indicates that should one of the stages fail, the rest of the stages should also fail. So each stage is set to sleep for 10 seconds. And let's run the job to see it in action. So all the stages are running in parallel. Let's change the script to get the stages to run in sequence to see the difference. So here we do not have nested stages and each stage sleeps also for 10 seconds. Let's run the job. So the job runs significantly slower as the stages execute sequentially. So now let's change the script to see how fail fast works. So the script is pretty much the same as the first example, which is the parallel example. But for stage 2, we have set the sleep timer to be 2 seconds as compared to 10 seconds for the other stages. And after that, it throws an error. So let's run the job to see what happens. So as you can see, all 3 stages are executing at the same time. After 2 seconds, stage 2 failed, and that resulted in stage 1 and stage 3 failing. I hope this has been useful. Let's move on to the next lecture. In this lecture, we will be covering the input step under stage section, which is useful if you want to allow user input, which will affect the build flow. It is important to highlight that the stage will pause after any options have been applied and before entering the stage agent or evaluating its when condition. If the input is approved, the stage will then continue. Any parameters provided as part of the input submission will be available in the environment for the rest of the stage. Let's see a simple example. Here we have the input step with the message option, which allows us to specify a high-level message for the input. Next, we have the OK option, where we can specify the text of the OK button. Next, we have the submitter option here, where we can specify users or groups that are allowed to submit the user input. For creating users, they are found under Manage Jenkins under Manage Users. For groups, you can get Jenkins to connect to LDAP or Active Directory. But for the sake of simplicity, we will just use users. Let's create a dummy user now. In this lecture, we cover the post section where there are steps that run depending on what condition the stage or build is in. Take note that the post section can appear at the end of a stage or at the end of the pipeline. The post condition blocks are these ones here. And remember that the execution of these steps are in this particular order. I will show you examples of the post section at the pipeline level, as it also works the same way at the stage level. Let's see an example. So in this example, we will demonstrate 3 post conditions at one go: success, failure, and always. Success only runs if the current pipeline or stage has a success status. And the same goes with failure, if the pipeline or stage has a failed status. And the always block will always run regardless of what the status is. So as you can see, we have commented out the error step so that the build will be successful. Let's run the job. Okay, so the build is successful. The success post condition is executed. So is the always block. Now let's go back and uncomment the error condition and rerun the job. Now the failure block is executed, but not the success one. And the always block is always executed. Now let's take a look at the changed condition. So with this example, the change block only runs if the current build status or the stage status has a different completion stage from the previous one. Take note that we are using a script block here. So if you're not familiar with the script block, there's a lecture on it. You might want to watch that first and come back to this again. So in this script block, there's a global variable called current build. You can find all global variables that are available to the pipeline under pipeline syntax and then clicking on the global variables reference link. Let me save the job first and show you where to find this. Some of these variables here are installed by plugins and not by Jenkins. So if you search for current build, there you go. That's the global variable being used by the script. So we are setting the result of the current build to be unstable. So let's get the build to run. So change this code because the previous build was failure and now it is successful. Now let's get it to be unstable. So as you can see, the color now is yellow, so it means that it's unstable. So you can see that the change block gets executed once again. So as long as the build or stage status keeps changing from the last one, this block will still get executed. Let's run it one more time. So the change block does not get called as the build status has not changed from the previous one. Now I will take this opportunity to also demonstrate the unstable condition. Let me add in the unstable block, which only runs when the current pipeline or stage has an unstable status. Let's save and run the job. And the unstable block is called. Now we look at the fixed condition. So the fixed block only runs if the current build or stage is successful and the previous run failed or was unstable. Basically, that means that it runs only when the build is fixed. So as our previous build was unstable, let's run this and see if it gets cold. And there you go, the fixed block was executed. Let's move on to the regression condition. So the regression block only runs if the current build or stage status is failure, unstable, or aborted, and the previous run was successful. So this is the opposite of fixed. So the last example was successful, and we have set this build to fail using the error step. So the regression block should get called. Let's run the job. And expected, the regression block was executed. Let's take a look at the aborted condition. Now, to get the build to abort, we are using the same trick as we did with unstable. We set the result of the current build to be aborted. And we have the aborted block here, right? Which runs only when the current pipeline or stage has an aborted status. So let's save and run the job. Okay, so the aborted status is denoted by a gray color. Okay, so the aborted block gets executed. Now let's take a look at the cleanup condition. In this lecture, we take a look at how we can make use of third-party Java libraries, like those found in Maven Central in our pipeline script. Let's create a job to see how we can do that. So with this example, we'll be using the add grep annotation to import the Apache Commons string utils library. So the add grep annotation comes from grep, which is the jar dependency manager of Groovy. You can check out this page for further details. Okay, so once you have imported the string utils library here, we call it inside our script to uppercase the text hello world. Note that we are not using a script block. Take special note to untick the use Groovy sandbox checkbox, or you will encounter a runtime exception that you're not able to find a class loader for grep. So let's run the job and see what happens. So as you can see, the lowercase hello world becomes uppercase hello world. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can load non-Groovy resources from our shared library. All resources will need to be stored in the resources directory. So let's go inside the resources com accelerated scale up directory, and we have a JSON file here which we will be loading into our pipeline script. So let's create a Jenkins job to see how we can do that. So here we are using the @library syntax to import the shared library, and also note the underscore here, which is used to import everything from the shared library. So in the script block, we call library resource to give it the location of our resource and assign it to a variable. And in next line, we use the echo step to print it. So let's run the job and see what happens. So as you can see, the JSON file is printed out. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can execute entire pipeline scripts in a custom step. So in the vars directory, we have a Groovy script called exec build or deploy.groovy, where we define a call method with a string parameter, which will determine which pipeline script to execute. Okay, so now let's create a job to see how this happens. So we are importing the shared library using the @library syntax. With this example, we are calling our custom step exec build or deploy with the build string parameter. Let's save and run the job. So you can see that the build pipeline script is executed. Now let's go back to configure. And change this to deploy. And the deploy pipeline script is executed. Now let's change it to something else. And the pipeline script for do nothing is executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we introduce scripted pipeline syntax. It's a more powerful way to create pipeline scripts as it allows the use of Groovy in your script. Note that scripted pipeline in most cases start with the keyword node. If you Google for answers to scripted pipeline problems on the internet and you encounter solutions that start with pipeline, then you must recognize immediately that sometimes the decorative pipeline solution is not directly applicable to your scripted pipeline problem. It also does get confusing if you are using declarative pipeline scripting and you come across solutions that are scripted pipeline based. Now let's take a look at a few basic examples of how scripted pipeline looks. Let's create a job. So at its most basic, we have a node block with an echo statement. Usually it's good practice to break down the script into stages, but it's possible to put everything into a node block without using stages. Let's run this and see what happens. Okay, so we get the echo statement printed out. Now let's take a look at another example. Going back to configure. So here we have a node block with a single stage called build with an echo statement. Let's run this. So here we have the build stage being displayed, and this is the output when we use stages. Next, I want to also show you how we can use the node block inside a stage. So this basically tells Jenkins that I want to execute the echo step in any node. Later on, we will see how we can specify which node to use to execute the echo step. Let's run this and see how it looks like. So as you can see, there are two statements here telling you where the script is running in, right? Okay, and the echo step is executed. Now, I want to also show you another way to use scripted pipeline without the node block. Going back to configure. So here we basically just specify the stages and no node block is used, and this scripted pipeline code is considered valid. Let's run this. And there you go. We have two stages being executed. Okay, now let's take a look at how we can get the echo step to execute on a slave node. Let's go into Manage Jenkins. Manage Nodes. Launching Agent Slave 1. Okay, it's now available. Going back into the Jenkins job. Okay, so here you can see that in the node block we have specified the label master, which is this current instance here, at the top level node block, and slave 1 in the inner node block. Now let's run this and see what happens. So from the console you can see that we are running the stage build inside slave 1. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can use Docker in scripted pipeline code. Let's create a Jenkins job. This is a basic example where we specify an image and assign it to a Maven image variable, and call the insight method to execute a shell command in the container to print out the Maven version. Let's run the job. So as you can see, the container being spun up with the image and the Maven command being executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can specify run arguments to Docker in scripted pipeline code. Let's create a Jenkins job. So this is a basic example where we specify an image and assign it to a Maven image variable. And when we call the insight method, the first parameter is to send in the Docker run arguments, where we specify an environment variable, some env equals to def, and the second parameter is a closure block to call the shell step to echo out the some env environment variable inside the container. Let's run the job. So from the console, you can see the container being spun up with the -e parameter being specified on the command line, and the word def, echo def, is printed out inside the container. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can get Docker to always pull in scripted pipeline code. Let's create a Jenkins job. In this example, we specify an image and assign it to a Maven image variable, and we call the pull method on it. This will cause a Docker pull command to be executed. And when we call the insight method, the first parameter is to send in the Docker run arguments, where we specify an environment variable, some env equals to def, and the second parameter is a closure block to call the shell step to echo out the some env environment variable inside the container. Let's run the job. So from the console, you can see that the Docker pull command is executed and the container being spun up with the image -e parameter being specified here, and the word def is printed out inside the container. Let's comment out the line where we call pull and rerun the job. Building again. So as you can see, Docker pull command is not executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can set the custom workspace for Docker in scripted pipeline code. Let's create a Jenkins job. In this example, we will be using the workspace step to specify a custom workspace for Docker to work in. This workspace step comes from the workflow durable task step. Right over here. Next, we then specify an image and assign it to a Maven image variable, and call the inside method to execute a shell command in the container to print out the Maven version. Let's run the job. So as you can see, the job is running in the node docker custom workspace directory. And you can see that Docker has specified the -w parameter, which indicates the workspace for Docker, which also happens to be node docker custom workspace. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can load an image from a registry URL for Docker in scripted pipeline code. Let's create a Jenkins job. In this example, we will be using the with registry method of the Docker global variable, and we specify as the first parameter the registry URL. We have used this key.io URL before in our decorative pipeline video on Docker registry URL. So the second parameter is the credentials ID, key.io, which we have used before in the decorative pipeline video. That's the credentials we are using here. Now we specify the image that we want to use. Same image as before in the decorative pipeline video. And we print out the environment variable using print-env. Let's run the job. So from the console, you can see that we are doing a Docker pull of the image from key.io, downloading it and spinning it up and printing out the environment variables. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can build an image from a Docker file with the standard naming of the file, which starts with an uppercase D Docker file, like this, in scripted pipeline code. And we will be making use of this GitHub repository. And same as before, we are just building from the Ubuntu latest image. Let's create a Jenkins job. So we are using the checkout step to check out from the repository. And we are using the build method of the global variable Docker. And we specify the name and tag in the name : tag format in the first parameter. We assign a new image to my custom Ubuntu image. And then we run the cat command inside the container to print out the OS details. So let's save and run the job and see what happens. So it's cloning the repository, it's building from the image file and tagging it the way we have specified, spinning up the image, spinning up a container using the image, and printing out the OS details. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can specify the location of the Docker file if it resides in a subdirectory in scripted pipeline code. And we will be making use of this GitHub repository that has a single Docker file in Docker file dir directory. Same as before, it just builds from the Ubuntu latest image. Now let's create a Jenkins job. So in this example, we use the checkout step to check out from the repository, and using the build method of the global variable Docker, we specify the name and tag here in the first parameter, and in the second parameter we specify the location of the Docker file, assuming that we are using the normal naming convention of a Docker file, which is an uppercase D Docker file. We assign a new image to my custom Ubuntu image, and then we run a cat command inside the container to print out the OS details. Now let's save and run the job. So we see the docker build command here with the directory that we specified is managed to pick up the Docker file and building an image from it, spinning up a container from it, and printing out the OS details. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can use a custom named Docker file in scripted pipeline code. And we'll be making use of this GitHub repository that has a single Docker file with a custom name, my custom name Docker file. And as before, it is just building from the latest Ubuntu latest image. Now let's create a Jenkins job. So we are using the checkout step to check out from the repository, and we are using the build method of the global variable Docker. We specify the name and tag in the name : tag format in the first parameter, and we specify in the second parameter the -- file option, and we put in the name of our custom of our Docker file in here. And note that you have to put this dot at the end here to indicate the current directory, or you'll get a Docker build error. We assign the image to my custom Ubuntu image, and we run the cat command inside the container to print out the OS details like before. So let's save and run the job. So there you go, it's checking out from the Git repository, and the Docker build command uses the -- file option followed by the single period. So it's managed to build the image running it, and printing out the OS details. So I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can use additional build arguments when building from a Docker file in scripted pipeline code. And we'll be making use of this GitHub repository that has a single Docker file. And same as before, it is just building from the Ubuntu latest image. Let's create a Jenkins job. So we are using the checkout step to check out from the repository, and we are using the build method of the global variable Docker, and we specify the name and tag in the name :tag format in the first parameter, and in the second parameter we are using the double dash tag option to specify another tag. And do not forget this period here to indicate the current directory. If we omit this single period here, we'll get a Docker build error. So we're assigning the image to my custom Ubuntu image, and we're running the cat command inside the container to print out OS details. So let's save and run the job to see what happens. I think I kicked off the build twice. So let's see. So it's building from the Docker file, and it's tagging it twice. The first time is from the first parameter, and the second time from the double dash tag, right? So we have two tags. So Docker spins up a container from the image, and it prints out the OS details. So I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can specify a custom workspace for building from a Docker file in scripted pipeline code. And we will be making use of this GitHub repository that has a single Docker file. And as before, it is just building from the Ubuntu latest image. Let's create a Jenkins job. In this example, we are using the workspace step from Workflow Durable Task Step plugin over here. And we are also using the checkout step to check out from the repository. We also use the build method of the global variable Docker, and we specify the name and tag of the image in the format of name: tag. And then we run the cat command inside the container to print out the OS details. Let's save and run the job and see what happens. So as you can see, we are running in this workspace, and the script is checking out from the repository. Docker has managed to find the file, building up the image, and take note that Docker is specifying the working directory to be using the custom directory that we have specified. and we are printing out the OS details here. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the retry and error step in scripted pipeline code. Let's create a job. Now, in scripted pipeline code, there is more flexibility in how we can use the retry block. In this simple example, we have encapsulated the error step inside the retry block to retry 3 times. Let's run this and see what happens. So, as expected, the error step was executed 3 times inside the build stage, and the build ended in failure. Now let's see another example. Okay, so in this example, we have encapsulated the build stage inside a retry block. Let's run this and see what happens. So the build stage was executed 3 times. 1, 2, and 3. And the build ended up in failure. Now let's see a third example. So in this example, we have encapsulated the entire node inside a retry block. Let's see what happens. So as you can see that the node was executed 3 times. Okay. 1, 2, and 3. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the timeout and sleep step in scripted pipeline code. Let's create a job. In scripted pipeline code, there is more flexibility in how we can use the timeout block. In this simple example, we have encapsulated the sleep step inside a timeout block to timeout in 1 second. Let's run this and see what happens. So the sleep step caused the timeout to happen inside the build stage, and the build ended up in aborted status. Now let's see another example. Now in this example, we have encapsulated the build stage inside a timeout block. Let's run this and see what happens. So the timeout happened at the build stage level. Okay, so now let's see a third example. So now we have encapsulated the entire node inside the timeout block. Let's run this and see what happens. So the timeout happened at the node level. So there are different ways in how we can make use of timeout in scripted pipeline code. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can use timestamps in scripted pipeline code. Let's create a job. Here we use the timestamps code block to encapsulate the build and deploy stages so that the echo statements in both stages will have timestamps. Let's save and run the job. Here we can see the timestamps printed out before the echo statements for both stages. Okay, so next let's take a look at how we can put a timestamp block inside a stage. Going back into configure. So in here, we only have the timestamps block inside the build stage, but not in deploy stage. Let's run this and see what happens. So only the build stage echo statement has a timestamp. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can use credentials in scripted pipeline code. Let's first create a job. So in here, we are using the with credentials function from the credentials binding plugin. Okay, it allows us to bind credentials to variables. As we have already set up a username password credentials, which is some username password in our previous videos, we can use them here in this example. And we are using the username password binding here. There are other bindings listed in the credentials binding plugin page. So let's search for username password. Right, there you go. So this is where the documentation for username password binding is found. Okay. So we are setting the username variable to some username and the password variable to some password. And within the credentials, within the with credential block, we echo the username and password. So let's save the job now. And I'd like to take this chance to show you where the credentials are stored. So we go to credentials here. And these are the credentials that were previously created. We have the some username password credential here and the some secret credential here, which we'll use later. Okay, so let's run the Jenkins job. So from the console, we can see that only asterisks are printed out for the username password. Now let's see how we can use multiple credentials in our scripted pipeline code. So going back to configure, As mentioned before, in our previous videos, we have created a secret text credential and we'll be using that here. As you can see, this is how we specify multiple credential bindings, and we are using the string binding for secret text. Okay, so if we search for string, so this is the one that we're using. Okay, let's run the job. So as expected, only asterisks are printed out even for secret text. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we implement the when directive in scripted pipeline. Let's create a Jenkins job. So here we have defined two normal variables, name and is groovy cool. And using the with env function, we declare a deploy to environment variable that can be used within the with env enclosing block, which also has a build stage in it. In the build stage, the when environment equals expression not all of and any of conditions are all represented by its groovy equivalents. For when environment, we are testing for the value of the env.deployTo variable. For the when equals condition, we are testing for the value of the name variable. For when expression condition, we are testing for the value of the isGroovyCool variable, and so on and so forth. Let's save and run the job to see the output. So the output is what we have expected. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we implement the branch condition of the when directive in scripted pipeline code. We will be making use of a GitHub repository, scripted when branch, and in it there is a single Jenkins file. And in here there are two stages, build master and build dev. I'm not exactly sure why the formatting is off, but I think you should be able to understand it. So we are using the environment variable branch name here to find out which branch of code we are building for. So if the branch name is master, we execute the stage build master, and if the branch name is dev, we execute the stage build dev. So there is another branch called dev, which has the exact same Jenkins file. So let's now create a Jenkins job. So this is going to be a multi-branch pipeline job. Adding the GitHub source. Saving it. Okay, now let's take a look at the master build. So the build master stage was executed, but not the build dev stage. Let's take a look at the dev build. So we can see that the build master stage was not executed, but the build dev stage was. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we implement building tag and tag conditions of the when directive in scripted pipeline code. We will be using a GitHub repository, and in it there's a single Jenkins file. We have if conditions that test for the environment variable tag name. So when the environment variable tag name is not null, we are building from a tag, and if it is null, we are building from a branch. If we want to detect if we are building from a specific tag, we can compare the value of the tag name variable to that specific tag, which is what we have done here for release 1.0. Note that we already have two tags here in this repository. Release 1.0 and release 2.0. They're all pointing to the same Jenkins file. Let's create a Jenkins job. This is going to be a multi-branch pipeline job. Adding the GitHub source. Remember to add discover tags. Saving it. Now let's go into the master branch build. So because the tag name is null, that's why it's printing out we are building a branch. Now let's take a look at the release 1.0 tag. Doing a manual build. So as you can see, the correct statements are printed out. Now let's take a look at release 2.0. So we can see that only one statement was printed out. I hope you find this useful. Let's move on to the next lecture. In this lecture, we look at how we can implement the changelog condition of the when directive in scripted pipeline code. We will be making use of a GitHub repository, which has just a text file, normal.txt, which contains some arbitrary text. We will be making changes to this text file so that we can put in different commit messages and rerun the builds. Let's create a Jenkins job. What we are having here is mainly Groovy code. Firstly, we check out the files from the repository, and then we declare a Boolean variable changelog found that tells us if we have found a changelog, which is a commit message that suits a certain pattern. Next, we declare a changelog set variable and assign it the change set property of the current build environment variable. We then print out the size of the changelog set. We loop through the changelog set and get each commit message. Note that we are also printing out the class name of an element of the changelog sets. We will refer back to this soon. if the commit message fulfills the regular expression here, changelog found variable will be set to true, and then we break out of both for loops. Note that after the for loop, we set the changelog sets variable to be null. This is to prevent Jenkins from serializing the variable, as the variable contains the git change set list object, which is not serializable. Otherwise, we will be getting not serializable exception in our Jenkins script. If the changelog found is true, the changelog found stage will be executed. If not, the changelog not found stage will be executed. Let's save the build and run it. As this is the first build, the build skips the changelog. Now let's make a change to the text file and commit the file. Now let's rerun the build. We see that the commit message fulfills the regular expression and the changelog found stage is executed. Now let's change the text of the text file again and give it a commit message that does not fulfill the regular expression. Let's rerun the build. We see that the commit message does not fulfill the regular expression and the changelog not found stage is executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we look at how we can implement the change request condition of the when directive in scripted pipeline code. We will be making use of a GitHub repository, which has a Jenkins file and a normal text file that contains some text. We will be making changes to the text file so that we can commit the file and create pull requests. And in the Jenkins file, we are printing out all the environment variables related to change request or pull request, and we have an if condition that checks if the pull request title is equals to when PR. We echo that we have found a pull request. If not, it prints out a pull request not found statement. Let's create a Jenkins job. We will be selecting a multi-branch pipeline job. Adding the GitHub source. Saving the job. Let's go to the master build. So as you can see, all the values of the change request variables are null, as it's not a pull request build. So going back to GitHub, let's create a new dev branch. And going to the console, do a git pull. And we are checking out the dev branch. Let's modify the text of the normal.txt file. Let's change it to 3. Okay, let's refresh the GitHub page. So normal.txt has already been updated. Now let's create a pull request. Let's put in the title to be when PR. That's what we're looking for. And create a pull request. Okay, going back to Jenkins. Let's scan the repository again. And the pull request is picked up. So you can see there's one pull request here. Let's take a look at the logs. Okay, so you can see that the change title is when PR and our pull request is found. And the other environment variables for change requests are populated, except for a few of them. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we implement the change set condition of the when directive in scripted pipeline code. We will be making use of a GitHub repository, which has just a text file and a JavaScript file. Both contains some text. We will be making changes to these files so that we can commit them and rerun the builds. Let's create a Jenkins job. What we are having here is mainly Groovy code. Firstly, we check out the files from the repository. Then we declare a Boolean variable change set found that tells us if we have found a change set which involves JavaScript files that ends with .js. Next, we declare a changelog set variable and assign it the change set property of the current build environment variable. We then print out the size of the changelog set. We loop through the changelog sets and get each file name. Note that we are also printing out the class name of an element of the changelog sets. We will refer back to this soon. If the file that was changed has a file name that ends with .js, change set found will be set to true. We then break out of both the for loops. Note that after the for loop, we change the changelog sets variable to be null. This is to prevent Jenkins from serializing the variable, as the variable contains the git change set list object, which is not serializable. Otherwise, we will be getting not serializable exception in the Jenkins script. If the change set found is true, the change set found stage will be executed. If not, the change set not found stage will be executed. Let's save the build and run it. As it's the first build, the build skips the changelog. Now let's make a change to the JavaScript file and commit the file. Now let's kick off the build. We see that the file name ends with .js and the change set found stage is executed. Now let's change the text of the normal.txt file and commit it. Let's rerun the build again. We see that the file name does not end with .js and the change set not found stage is executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we implement the parallel block, including the fail fast option in scripted pipeline code. Let's see a simple example. So this is the syntax for running parallel code in scripted pipeline code. Note that there is only just one stage. 3 branches here and the fail fast option. So each branch is set to sleep for 10 seconds. Let's run the job to see it in action. So from the console, you can see that it is described here as branch instead of stage. And even on the main Jenkins job page, you can see that there is only just one stage. Now let's change the script to run sequentially. So as before, each stage is also sleeping for 10 seconds. Let's run the job. Okay, so you can see that it's executing in sequence. Now let's go back to the main Jenkins page. You can see that there are 3 stages here. To see how fail fast works, please view the decorative pipeline video on running parallel stages. I hope this has been useful. Let's move on to the next lecture. In this lecture, we will be covering how to implement input in scripted pipeline code. Let's create a Jenkins job. So here we have declared a variable called user input, and in the build stage we have assigned the return value of the input step to the user input variable. And once the user proceeds with the input, we echo out what the user has selected using the user input variable, like user input.environment, user input.version, and etc. The parameters to the input step should not look unfamiliar to you, as we have already covered them in the decorative pipeline videos. Let's save and run the job. And as expected, the script prints out the user input. Now, what if we want to ensure that if the user does not key in the input in a period of time, the build does not get stuck? What we can do is to wrap the input code in a timeout block. Let's take a look. Now we have wrapped the input inside a timeout block, and for the sake of demonstration, we have set the timeout to 1 second. Let's run the job. So as you can see, even if there is no user input, the build times out and ends up in aborted status. However, it does not get stuck. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we implement post in scripted pipeline code. Let's create a Jenkins job. So what we have here is a try, catch, finally construct, which comes from Groovy. So if you know a language that has these same constructs, you wouldn't be too unfamiliar with how it works. So for those who are unfamiliar, try, catch construct is used to execute a block of code and to handle any exceptions that might arise from it. The finally block is used to execute code once the try block completes. The catch section here doesn't do anything in this example, but I have listed it just for the sake of completeness of the try, catch, finally block. We can also just have the try and finally sections only. The finally section is where we implement post. So you can see that there are a fair number of if conditions that checks for statuses of the current build and the previous build to decide whether to execute the code that it encapsulates. The scripted pipeline code has currently set the current build to success. So let's just run the code and see what happens. So as you can see, the always code is executed, success code is executed, and the cleanup code is executed. Now let's go back to change the status of the build to be aborted. Let's save and run the job again. You can see that the always code, change code, regression code, and aborted code and cleanup code are executed. Now let's change the status of the build to be unstable and see what happens. You can see that now the unstable code is executed. Now let's change it to be failure. And the failure code is executed. We can also put this try catch block within a stage so that it only runs within a particular stage. Let's take a look at an example. So here we not only have a build stage, but also a deploy stage. And the try catch block is within the build stage. Okay, so now let's save the job and run it. So as you can see, for the deploy stage, it only prints out the echo statement. I hope you find this useful. Let's move on to the next lecture. In this lecture, we look at how we can implement build discarder option in scripted pipeline code. Let's create a Jenkins job to see how we can do that. So what we have here is we specify the build discarder property to the properties function, and we are specified to keep the build logs to just 1 for demonstration purposes. Let's save and run the job. All good there. Let's rerun the job again. And we've got to refresh the page to see that only one build is kept. Okay, so build 2 is the only one that's kept. Let's build another time. Build 3. Okay, let's refresh the page. Okay, so only build 3 is left. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement disable concurrent builds in scripted pipeline code. Let's create a Jenkins job to see how we can do that. So here we have specified the disable concurrent builds property to the properties function. And in the build stage, we cause the build to sleep for 10 seconds so that we can show concurrent builds are prevented when disable concurrent builds property is specified. Let's save and run the job. So let's run multiple builds. Build 1. Build 2 is pending, waiting for build 1. Build 3 is pending, waiting for build 2. So you can see that subsequent builds are pending, waiting for the previous build to finish before executing. Now let's comment out the disable concurrent builds property, and also remember to uncheck this tick box, right? The do not allow concurrent builds tick box. And let's comment out the property. Let's save it. And let's rerun the build multiple times. So now you can see the behavior is different. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement override index triggers in scripted pipeline code. We will be making use of a GitHub repository which contains a single Jenkins file. And in the file, we have initially commented out the override index triggers property first. And we have a build stage which prints out hello world 1. Let's create a Jenkins job. Selecting a multi-branch pipeline job. Adding a GitHub source. Saving the job. Now a schedule build was created for master branch. Going into master. And we see hello world 1 printed out. Now let's uncomment the override index triggers property and set it to false. To disable branch indexing triggers, and we are changing the hello world to hello world 2. Okay, so I will be using a commit script to help me automate the committing and pushing of code to the repository, but the git commands are essentially the same as before. So we've got the git add, git commit, and git push origin commands as before. So let's scan the repository. The build is still scheduled for master branch. And we go into the master branch. And we see that hello world 2 is printed out. Now, for the override index triggers property to take effect, we do a manual build. Okay, hello world 2 is printed out. Now let's change to hello world 3. and committing the change to the repository. Let's scan the repository again. Now the build is not scheduled. Okay, so now let's set the override index triggers to true. Setting hello world to 4. Saving it and pushing to the repository. Scanning the repository. The build is still not scheduled. Let's do a manual build. We see that hello world 4 is printed out. Now let's change to hello world 5 and pushing it to the repository. Okay, now let's scan the repository. And you can see that the build is scheduled. Now let's go into master. And we can see hello world 5 is printed out. So I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement override index triggers in scripted pipeline code. We will be making use of a GitHub repository which contains a single Jenkins file. And in the file, we have initially commented out the override index triggers property first. And we have a build stage which prints out hello world 1. Let's create a Jenkins job. Selecting a multi-branch pipeline job. Adding a GitHub source. Saving the job. Now a schedule build was created for master branch. Going into master. And we see hello world 1 printed out. Now let's uncomment the override index triggers property and set it to false. To disable branch indexing triggers, and we are changing the hello world to hello world 2. Okay, so I'll be using a commit script to help me automate the committing and pushing of code to the repository, but the git commands are essentially the same as before. So we've got the git add, git commit, and git push origin commands as before. So let's scan the repository. The build is still scheduled for master branch. And we go into the master branch. And we see that Hello World 2 is printed out. Now, for the override index triggers property to take effect, we do a manual build. Okay, Hello World 2 is printed out. Now let's change to Hello World 3. And committing the change to the repository. Let's scan the repository again. Now the build is not scheduled. Okay, so now let's set the override index triggers to true. Setting Hello World to 4. Saving it and pushing to the repository. Scanning the repository. The build is still not scheduled. Let's do a manual build. We see that Hello World 4 is printed out. Now let's change to Hello World 5 and pushing it to the repository. Okay, now let's scan the repository. And you can see that the build is scheduled. Now let's go into master. And we can see Hello World 5 is printed out. So I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement skip stages after unstable in scripted pipeline code. Let's create a Jenkins job to see how we can do that. So here we have two stages, build and deploy. In the build stage, we set the current build to be unstable. And before executing the deploy stage, we check if the current build is not unstable, which it won't be. And the deploy stage is expected to not get executed. Let's run the job. So you can see that only the build stage was executed. Now let's change the build status to success, for example. And rerun the job. Now both stages are executed. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement checkout to subdirectory in scripted pipeline code. We will be making use of a GitHub repository which contains only a single text file. Let's create a Jenkins job. So here we are using the WS step, which allocates a new workspace. This step comes from the Workflow Durable Task Step plugin over here. And when we call the checkout step, it will check out into the new workspace, which is the subdirectory of the Jenkins job workspace. Let's run the job. From the console, you can see that the job is running in this workspace. Right, now let's go into pipeline steps. Allocate node start. Go into the workspace. Go into some sub-dir. And you can see that the normal.txt file from the repository was checked out into this directory. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can achieve the same behavior of new container per stage option of the option directive in scripted pipeline code. Let's create a Jenkins job. So what we have here are two stages, and in each stage we specify an image and assign it to a Maven image variable and call the inside method to execute a shell command in a container to print out the Maven version. It's essentially the same as the scripted pipeline example of Docker image, but with more than one stage. Let's run the job. Looking from the console, the container ID is different for each stage, right? And you can see that the container starts and stops within each stage. Okay, so I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be looking at how we can implement parameters in scripted pipeline code. Let's create a Jenkins job. So what we have here is specifying the parameters property together with the kind of parameters that we want to use, like string, boolean, param, choice, password, file, etc. We have already seen the parameter types before in our declarative pipeline videos for parameters. At the end of the script, we print out the values of the parameters using the params object. Let's save and run the job. We will need to run the job at least once to configure the build with the parameters before we can run the job again with parameters. So we have now run it once. Let's refresh the page. Now you can see that the build now link has changed to build with parameters. Now let's click on the link. and we are presented with the parameters here. So let me just click on build. And we can see that these are the parameters that we have selected. Now when we go into the configure screen, you will see that we have additional options here to choose from. These came from our scripted pipeline code. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be covering how to use tools in scripted pipeline code. Let's create a Jenkins job. So here we have declared a variable called Maven Home. And we are using the tool function to specify the tool that we want to use and the type of it. The tools that we want to use need to be pre-configured under Global Tool Configuration in Manage Jenkins. Two versions of Maven are already installed and configured on our Jenkins server, so let's take a look at that in Global Tools Configuration. So we go to Manage Jenkins, Global Tool Configuration, Maven installations. So we have these two Maven installations here. Okay. So after we have assigned the variable, we call the shell step to print out the Maven version. If you want to use other tools, you can go into pipeline syntax and use a snippet generator. Let's save the job and go there now. Going into pipeline syntax, snippet generator, let's search for tool. And if you select Maven, you'll find that the two Maven installations that we have seen before are listed here. And we click on Generate Pipeline Script to get the code snippet that we can use in our pipeline script. So let's now run the job. So from the console, you can see that the correct Maven version is printed out. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement the cron option of the triggers directive in scripted pipeline code. Let's create a Jenkins job. So here we are using the pipeline triggers property, and we have specified the cron expression here. I've already covered what the cron expressions are in my previous videos on cron, so I won't be covering them here. You can also use the other variants of the cron expressions which are commented out here. Okay, and we have a build stage that prints out hello world. Let's save and run the job. Okay, so we see hello world printed out here. Going back into configure, we find a new section, build triggers, and you'll see a cron expression in the text box as in the previous videos on cron. So I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement poll SCM option of the triggers directive in scripted pipeline code. And we will be using a GitHub repository that has a normal.txt file that contains some text so that we can make changes to it and rerun the builds. Let's create a Jenkins job. So in here, we are using the pipeline triggers property and have specified a poll SCM expression here. We have specified to Jenkins that we want to poll GitHub every minute, every hour, every day of the month, and every day of the week. And we are also using the checkout step here in the build stage, which will check out the code. And in our case, that will be normal.txt. So let's save and run the build. Okay, all good here. Now let's go back to configure. And you will see a new section here under build triggers, which has the polling configuration that we have specified in our script. I would also like to bring to your attention this link here, git polling log, where you can see when the repo was last polled. Okay, so now let's update normal.txt and commit the changes. Okay, so we've changed the normal.txt from some text 1 to some text 2. And I'll be using a commit batch file here, commit script batch file, to automate the commit and pushing of code to the remote repository. So as we have set the polling to every minute, we will refresh the git polling log page to see if there are any changes. So changes have been found and a new build has kicked off. Okay, so let's go into pipeline steps, allocate node start, and we see that normal.txt has the latest text. So I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can implement upstream option of the triggers directive in scripted pipeline code. Let's create a Jenkins job. So what we have here is the triggers property, where we have specified the upstream parameters, which tells Jenkins that this job is to build when upstream jobs scripted upstream job 1 and 2 are built with a success status. Available statuses are unstable, failure, not built, and aborted, and the class type to use is Jenkins triggers reverse build trigger. Now let's save this and create the upstream jobs. So I'm now just going to open all 3 jobs in different tabs. And I'm going to run job 1. Okay, all good. Running job 2. All good as well. And let me just run the main job for the first time. Okay, so going into configure, you'll see that there's a new section under build triggers with the configuration that we have specified in the scripted pipeline code. So now let's run job 1. Okay, so we can see that the build 2 of the main job has kicked off. Now let's run job 2. Build 3 has kicked off. Of the main build 3 of the main job has kicked off. Now let's set job 1 to be unstable. Okay. And let's build job 1. Okay, going back to the main job. We just wait for a few seconds. Let me just refresh the page as well. Okay, so no new build was kicked off. Now let's kick off job 2. Okay. And build 4 was kicked off. So I hope you find this useful. Let's move on to the next lecture. Congratulations and thank you. You have made it to the end of the course. We have covered a lot in this course and I hope that it has accelerated your understanding and application of Jenkins Pipeline as code. Please take the time to leave a review and rate the course. If you have any feedback on how I can make the course better, please let me know so that I can improve. And if you also have any questions that you had that I did not answer in my lectures, please feel free to message me. I will continue to add more lectures to the course, so this is not the final version of it. Please let me know what topics you want me to cover. So once again, congratulations and I will see you online. In this lecture, we will be looking at how we can get the output of a shell command and assign it to a variable. There are usually 2 things we want from executing a shell command or shell script: the output of it or the exit status of the shell script. So let's take a look at how we can achieve that. Let's create a Jenkins job. As we want to capture the output of the shell script to a variable, we can do that in scripted syntax or inside the script block in declarative syntax. But with this example, we will be using scripted syntax. So as you can see, we have defined a variable called shell output, to which we will be assigning the standard output of the shell script. We use a shell step, which you can get from the Nodes and Processes plugin right here. And we will specify the script parameter to be ls-al, and well, which basically returns the directory contents, and the return standard out parameter to be true. This tells the shell output, the shell step, to return the standard output. Note the trim method that is called at the end of the shell step. This trims the return output to remove any trailing new lines. For the second shell step, we specify another parameter, return status, to be true, which tells the shell step to return the exit code of the shell script. For the third shell step, we give a negative example where the shell script returns a non-zero value, which usually indicates an error. We will come back again to this commented out code later. For the fourth shell step, we specify both parameters and we see which parameter takes precedence as to what is being returned. Let's save and run the job. So from the console output, you can see that the return value for the first shell step is the output of the script. Okay, now the second shell step returns the positive exit status of the script, and the third shell step returns a negative exit status of the script, and the fourth shell step returns the exit status of the script, which tells us that the return status parameter takes precedence over the return standard out parameter when both are specified. Now, going back to the configure page, let's now uncomment the code that checks for the return status of the script and rerun the script again. This time you can see that we have made the build to fail based on the return status of the script. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at how we can create environment variables and use them in a shell script. Let's create a Jenkins job. Here we start off with creating two variables, one that starts with env and the other a groovy variable. We assign env.envvar1 to be John and the groovy variable to be Smith. Okay? We use the shell step to echo the environment variable in a shell script, and we use the echo step to print out the groovy variable, not env var1 in the pipeline script. Take special note that both these echoes are different. One works within a shell script and the other in the Jenkins pipeline script. Next, we try to print out the not env var1 groovy variable inside the shell script. Next, we will use the with env step, which you can find it here. Okay? To specify one or more environment variables that can only be used within a block. And in here we have env var2 and we have mvn version. Within the block we use a shell step to print out the value of env var2. Okay? And also to execute the maven or mvn command to get the maven version. And lastly, we print out all the environment variables available within the shell script inside the block using print env command. Now, once outside the block, we print out the env var2 and the mvn version environment variables to see if they exist outside the with env block. Now let's save and run the job. Okay, so I'm just going to be putting the console output and the code side by side. Okay, so we can see that we are able to print out the environment variable env var1, okay, in the shell step right here. Okay, and we are able to print out the groovy variable within the pipeline script. So you can see that we have Smith printed out here. But however, we are not able to print out the groovy variable inside the shell step because it doesn't exist. Okay, now as we move to the env, the with env block, right here. Okay, maybe I just move this to the bottom. You can see that we can print out env var2, okay, which is groovy, right? And we can print out the Maven version. Okay, let me just scroll down. And we can print the Maven version here. Okay, ambient double dash version. Okay, and we can find that the env var2, okay, env var2 and ambient version, and also env var1, okay, which was specified at the top of the script here. They're all available within the shell script, okay, inside the with env block. Now, after the with env block, we try to print out the env var2 and the mvn version environment variables, but they do not exist. Okay, I hope you find this useful. Let's move on to the next lecture.
In this lecture, we cover Maven integration by using the with Maven step, which configures a Maven environment to use within a pipeline block. We will need to have this plugin installed in our Jenkins setup. In order to demonstrate this plugin, we have a Java Maven project in here with its own pom.xml. A calculator class, and its own test case. Let's create a Jenkins job. So here is a first example of using the with Maven step. First, we clean the workspace. And we do a git pull of the Java project into the workspace. Next we have the with Maven block, and we have specified a Maven parameter here that points to the Maven installation we have configured in Jenkins Tools configuration. You can see that we have two Maven installations on the system, Maven 352 and Maven 305. Now, going back to create Jenkins job page, and within the with Maven block we call mvn clean install. Let's save and run the job. So from the console, you can see that we are using Maven 305 to compile the Java project. And the job is run successfully. So now we change the Maven version to 352, let's do just that. Going back into Configure, we change it to 352 and rerun the job. And you can see that the Maven version is now changed to 352. And the build is successful. Before we go to the third example, I just want to show you we have a few repositories set up in their locations. We have one repository here for Maven version 305 and it's not empty as it was populated by the previous build. And here we show the repository that Maven 305 is pointing to. We have another one for Maven version 352 and it's not empty due to previous builds. And here we show the repository that Maven 352 is pointing to. And we have another one here, config file Maven repo, we will be using that later. And we have another one here called local Maven repo, empty as well, and I will be showing how we use that later. Okay, so let's go back to configure and take a look at another parameter of the with Maven block. So in this third example, we have a parameter here that specifies a local repository. This repository points to the local Maven repository which I have just showed you. And this repository will be used instead of the one specified in the settings.xml in the Maven 352 installation. Take also special note of the -x parameter that I have specified in the mvn command. This will print debugging messages that will let us see which repository is being used. We now remove all contents in the Maven 352 repo, just to make sure that we are not using it when we run the job. Let's run the job. From the console, you can see that we are using the local Maven repo. And also the global Maven settings is taken from the Maven installation. But clearly this value here is overriding whatever that is set in global settings. Now let's see if the Maven 352 repo is populated or not. Okay, so it's still empty. Now, let's go to local Maven repo. And we can see that the artifacts are downloaded to this directory. Let's now take a look at another parameter called the Maven settings config parameter. Going back to configure. Here, we have specified that we want to take the Maven settings from a configuration file that is pre-specified. You can see that we have a blank value here which we will need to fill in. This value is specified in Jenkins managed files. Let's save this job first. Going into Manage Jenkins. Managed Files. In order to have this available, we need the Config File Provider plugin. Let's now create a new Maven settings configuration parameter. Choosing Maven settings.xml. Putting in the name and comments. And here we specify that the repository location to be used is config file maven repo. Let's save it. Copy the ID and go back into the Jenkins job. Paste it as the value of Maven settings config parameter. Note also of the -x parameter that we have specified as part of the mvn command. This is a debugger flag which will help us see more information inside Maven. Going to the command line, we remove all artifacts in the Maven 352 repo, just to make sure that Maven is not using this repo. Let's run the job. So from the console, you can see that Maven is using the config file Maven repo and not the Maven 352 repository. Let's go to the command line. We list the contents of the Maven 352 repository. And we see that it is empty. Now we list the contents of config file Maven repo. We see that the artifacts are downloaded here. Maven is still using the global settings.xml of Maven 352, but the settings specified by Maven settings config parameter takes precedence. There is also another Maven setting called Maven settings file path, which allows us to specify the location of the settings.xml that we want to use. So let's go back into configure. This is the Maven settings file path parameter, and we continue to use Maven 352. But we specify the location of our settings.xml file to be Maven 305. Going to the command line, we remove the contents of the Maven 305 repo. And show that it's empty. And we remove contents of Maven 352 repository as well. And we confirm that it is empty. Let's save and run the job. So you can see that Maven 305 repository is being used, which tells us that Maven settings file path parameter is in effect. Global settings are still for Maven 352. Going back to command line. We list the contents of the Maven 305 repository. And the artifacts are downloaded there. Now we list the contents of the Maven 352 repository. It's empty. So Maven is still using the global settings.xml of Maven 352, but the settings.xml specified by Maven settings file path takes precedence. Now what if all three parameters, Maven settings file path, Maven settings config and Maven local repo are specified? Let's take a look. Going back into configure. We have now specified all three settings, Maven settings file path, Maven settings config and Maven local repo. Maven is using 352. Maven settings file path is pointing to Maven 305. For Maven settings config, we go back to managed files and copy the ID. And paste the value here. Now, Maven settings config is pointing to config file Maven repository. And Maven local repo parameter points to local Maven repository. Let's run the job to see what happens. So local repository is using local Maven repo, which tells us that Maven local repo parameter takes precedences over the other settings. Now what if we remove Maven local repo parameter? Let's go back again to configure and remove Maven local repo. Let's save the job. Do a fresh build. Now the repo being used is the one from the config file, which is config file maven repo. Going back to configure. This tells us that between Maven settings config and Maven settings file path, Maven settings config will take precedence. There is another parameter that I would like to show. In all previous examples, we are using Java 8, but if we wanted to use a different Java version, we can use the JDK parameter. Let me just copy the new example code. We add the JDK parameter in here to use Java 11. Take note that Java 11 needs to be pre-configured and manage Jenkins, Tools configuration. Here we have Java 8 and Java 11. Let's go back to the Jenkins job, save it and run the job. Going by the console, the Java version is Java 11. There is another parameter called Maven Ops, which allows us to specify Java options. Take note that this is not specifying Maven options. Let's go back into configure. We have added the Maven Ops parameter in. To print command line flags. And to use the concurrent mark sweep garbage collection for Java. Let's now save and run the job. So from the console, you can see that the values of Java flags are printed out. And also a warning message from Java that concurrent mark sweep garbage collection will be phased out. Now, when we remove the Maven Ops, these messages do not appear. Let's change the script and see. Now, we do not see the messages that we saw earlier appear. Last but not least, when we go back to the main Jenkins job page, you can see that the artifacts of the build are being published. And on the right, there is this test result trend graph here that shows how well your unit tests are doing over time. If you want to enable or disable these two sections here, what you can do is going to the Maven integration plugin page, under Report Publishers, you can use the Artifacts Publisher and the Unit Publisher options of the with Maven block. Let's see an example. So here we have specified disabled to be true, which means we want to disable Unit Publishing and Artifacts Publishing, which will remove the artifacts and test result trend graph that we saw earlier. Let's run the job and see what happens. Now you can see that your artifacts are not published, and also test result trend graph is no longer there. If you want to re-enable them again, going back into Configure, set the disabled value to false, and rerun the job. Going back to the main job page, you can see your artifacts and test result trend graph again. There are other options in here that you might want to explore further. For example, Maven Global Settings Config, and other report publishers. I hope you find this useful. Let's move on to the next lecture. In the last lecture, we showed you the test results trend chart. One thing that I forgot to mention was that you can click on the chart and see what the tests are, which are passing or failing. You can click on the package to get the list of test classes. And clicking on the test class, we can see what the test cases are. In this lecture, we show you how we can use the Jacoco plugin to display the test coverage of your Java project. For this purpose, we will be making use of a Java project called Simple Java Project with Jacoco. Everything is the same as the Java project in the previous lecture, but the pom.xml has been updated to use the Jacoco Maven plugin to generate the test coverage. Now let's create a Jenkins job to see things in action. So here, we have the sample pipeline script as the previous lecture. And we want to view the test result trend graph and publish the artifacts of this build, so we set both the disable parameters to false. Before we save and run the job, our Git URL is now pointing to our new GitHub project, Simple Java Project with Jacoco. Let's now save and run the job. OK, from the console here, we see the Jacoco Maven plugin and also the Jacoco plugin in action here. It detects the existence of the Jacoco coverage files created by Maven and publishing the results. Let's go back to the build page. We see only the code coverage trend graph but no test result trend graph, as we will need to run it for more than once to have the graph appear. Let's run the job again. Now we see that the test result trend graph appears. So from here we see that we have 3 test cases, 4 covered lines, and 1 missed line. Clicking on the code coverage graph or the coverage report option on the left, we can see that there is a nice coverage summary and the coverage breakdown by package. Clicking on the package name, we see the calculator source file. And clicking on that, we see that the multiply method is not covered by our test cases. This is the missing test case, and because we have imported our Java project into Eclipse IDE. We uncomment the multiply test case. Commit the file. And push the code to GitHub. Now going back to Jenkins page, we rerun the build. So once the build has finished, we go back to the job page and we see that the test result trend graph has shown an increase in test cases to 4 and the code coverage graph shows there is an increase in lines covered and a decrease in missed lines. So what if we wanted to be able to set the status of the build to reflect the code coverage of the Java project? We can do that by going into pipeline syntax, searching for Jacoco. And we have a whole bunch of parameters here that we can set for Jacoco. But we will leave values for most parameters as default. But the values that we are more interested in are the threshold values here. So to keep things simple, we will set the build to be successful if the method code coverage hits the threshold at 75% and above. So if we leave percentage class here to be 0, we are telling Jacoco that any percentage of class coverage is acceptable to set the build to be successful, amongst other thresholds we can set. We also set the build to be unstable if the method code coverage is between the threshold of 50% and 75%. Below that 50%, the build fails. And if the code coverage percentage difference, which is also called the delta thresholds, in any of the metrics, like the line coverage, branch coverage, etc., between the last successful build and the current build is 40% or more, we fail the build. You can click on the question marks here to get more information on what the thresholds mean. We must also tick these two checkboxes. So once we have these values in place, we click on the Generate Pipeline Script button that will give us the Jacoco step line here, and we copy the generated script. Going back to Configure. Before we add in the Jacoco line, we need to disable the Jacoco report publisher within the with Maven block. This is so that we do not want Jacoco to process the code coverage twice, once by the with Maven block and another time by the Jacoco step. Now, we add in the Jacoco step line we copied just now. Let's have one last look. Let's save the job. Running the build once again. We currently have 100% test coverage, and these are the thresholds we have set here. Overall coverage is 100%, and that is all above the max method coverage of 75% and minimum method coverage at 50%. Min-max thresholds check is successful. We see the current delta values here, and also what we have set here in the results of the delta thresholds check is successful. Since we currently have 100% test coverage, so we will comment out one test case, which will bring down our code coverage. Let's comment out the multiply test case. Committing the code. And pushing to master branch. Let's rerun the Jenkins job. Looking at what Jacoco plugin prints out, overall coverage has dropped, method coverage is 80 but still above max method coverage of 75%, so we are good here. And also min-max thresholds result is showing success. Delta thresholds we have set are at 40. And the actual delta values are at 20%, which is lower than the 40% that we have set, and it says here that results of delta thresholds check is successful. Okay, so let's continue to decrease the number of test cases by 1. Committing the file. And pushing to master branch. Rebuilding the job. You can see that in overall coverage, method is 60, which is below 75. And min-max thresholds result is unstable. Delta coverage is still around 20%, which is well below 40%. Results of delta thresholds check is still success. Ultimately, the build status is unstable. Let's continue to reduce the number of test cases. Rebuilding the job. You can see that in overall coverage method is 40, which is below minimum method coverage of 50%. And min-max thresholds result is failure. Delta coverage is still around 20%, which is below 40%. Results of delta thresholds check is success. Ultimately, the build status is failure. Now we want to show you how we can get the build to fail based on the delta coverage thresholds. Do not forget we have set that if the code coverage percentage difference in any of the metrics, like the line coverage, branch coverage, etc., between the last successful build and the current build is 40% or more, we fail the build. So we first set the build to be successful by uncommenting all test cases. Rebuilding the job. Now the build is successful. Let's now comment out two test cases. Rebuilding the job. Now we see that overall coverage is 60, but that's still between 50 and 75%, so the min-max thresholds result is unstable. But delta coverage has exceeded 40%. So results of delta thresholds check is failure. And thus the build ends in failure. I hope you find this useful. Let's move on to the next lecture. In this lecture, we build on top of what we did in the previous lecture on Gcoco plugin. We will be making use of the SonarQube plugin to do integration with SonarQube. For those who do not know, SonarQube is a popular software that is used for code quality checks as part of the build process. Now, before we begin, we already have SonarQube installed, and as you can see, there are no projects here. We have also installed the SonarQube plugin in Jenkins. And we have configured Jenkins to connect to SonarQube under Manage Jenkins, Configure System. Ensure you have this checked. Give the SonarQube installation a name and also the server URL, which is the same IP address as the SonarQube we have installed. When you install SonarQube, you will be given an authentication token which you put in here. And save the configuration. Once we have everything in place, let's now create a Jenkins job. We are using the same example as we did in the Gcoco lecture. But we have Git URL pointing to the simple Java project with SonarQube Git project. The code project is found here and it's pretty much the same as the Gcoco project. But the package name has been changed to include SonarQube. And there are no changes to the pom.xml. We are still using Maven 352. And we are using the with SonarQube env step. The name here is the same as what you have specified in Jenkins Manage Configure. Inside the step, we call mvn sonar. This will connect to the SonarQube server to scan for code quality. Let's save and run the job. Once the build has finished, let us search for the link that will take us to the SonarQube page for this project. From here, we see that we have 100% code coverage, 0 bugs and vulnerabilities, no technical debt and code smells. Our quality gate is pass status. So what is a quality gate? It's basically a set of conditions that we have set to indicate if our code is production ready. Let's add in a bug and a vulnerability in the Java code on purpose to see how SonarQube will process it. We have already imported the code into Eclipse. And going into the calculator class, we add in a bug here. We will need to update the expected value in our test case so that it passes as the expected value has changed. Going back to the calculator class, we want to add in a vulnerability here. Let's commit the code. Publishing to GitHub. Rebuild the job. The build is successful. Now we refresh the SonarQube page, and we see that there is now one bug and vulnerability reported. Our quality gate has failed, but however, our build has still passed. So how do we make the build fail if our quality gate fails? Let's go back to configure. Here we have created another stage called Quality Gate. Where we have a wait for Quality Gate step. What this does is it waits for SonarQube to notify Jenkins on the results of the Quality Gate. There is a timeout step in closing it just in case it takes too long for SonarQube to notify Jenkins, and the stage can just exit out after 1 minute. If the quality gate return status is not OK, we fail the Jenkins job. In order for SonarQube to inform Jenkins on the status of the quality gate, it needs to know how to connect to Jenkins. You need to go to SonarQube, Administration, Configuration, webhooks. Put in the name and Jenkins URL as such. Ensure that it ends with SonarQube webhook. This is how SonarQube notifies Jenkins of the quality gate status. Going back to Jenkins. Let's now save and run the job. Going by the console, you can see that the timeout is set to 1 minute and Jenkins checking the status of the SonarQube task on my SonarQube server. The task progresses from pending to success and Jenkins is notified that the quality gate result is error. And the build fails. Now, let's remove all bugs and vulnerabilities. Commit the code. And pushing it to GitHub. Rerunning the build. Now the build passes when the quality gate has passed. Going back to SonarQube. Quality gate has passed and everything is looking good. I hope you find this useful. Let's move on to the next lecture. In this lecture, we will be covering how we can trigger downstream jobs from a parent job to child jobs in Pipeline script and how to pass data between them. We will be making use of the build step. Let's first create a parent job. Here we have called the build step to execute a downstream job called build step child job 1 which has not been created yet. We specify a string parameter called deploy env with a value of development env. The code that is commented out is an alternative syntax of specifying a string parameter. We shall take a look at that later. There are many types of parameters you can pass to the downstream child jobs. Feel free to experiment with the different parameter types. Let's save the job. Let's now create the downstream child job. Take note that we need to parameterize the child job or else the parent job will not be able to pass data to it. We have specified the same variable called deploy_env parameter here in the child job. In the build stage, we can either reference to the deploy_env parameter using params.deploy_env or just deploy_env. Let's save and build the child job 1 to initialize it first. It will end with an error, but that's okay. Let us just refresh the page now. Take note that the Build Now link is now built with parameters. Let's now build the parent job. Now as the parent job is building, we can also see that the child job has been kicked off. And it has managed to print out the deploy_env parameter value. Going back to the parent job. You can also see from the console that the parent job is scheduling and building the child job 1. Going back into configure. I want to use the alternative syntax for the string parameter. Let's save and run the job again. You can see that the behavior of the parent job is same as before. I would now also like to show you how you can use pipeline syntax to generate the build job script. Clicking on the pipeline syntax link, select build job from the drop-down list and put in the child job name. Which in our case is build step child job 1. And as soon as you do that, your parameter appears and you can put in a value in there. Click on Generate Pipeline Script and you will get the sample script to use. Next, we will demonstrate how to use the optional parameter, propagate. This is an optional parameter that causes the parent job to fail if the child job fails if the value is true. Let's update the child job 1 to fail. Going into configure. Here, we have set the result of the current build to fail. Saving the job and going back to parent job. We update the script to include the propagate parameter, which is set to true. We assign the result of the build step to a variable called buildJobReturnValue, and we echo the result of the child build. Now, let's save and run the job. Going into the console, we see that child job 1 has failed and also caused the parent job to fail, but however we do not see the echo line printed anywhere. The parent job failed and the script just ended. Now let's change the propagate parameter to false. Let's now rerun the job. So as you can see from the console, the parent job is successful even though the child job is not, and we are able to print out the build status of the child job using the result property of the buildJobReturnValue variable. What we can potentially do with this variable is to fail the parent job, if we wanted to, by using an if statement, but it's up to you to do what fits your situation. The next thing I want to demonstrate is the wait and quiet period optional parameters. It's a bit hard to showcase the behavior of quiet period unless you want to wait for a long time to demonstrate the quiet period in action, but I will just put it in here anyways, as an example. The wait parameter tells the parent job to wait for it to finish before executing the following code. Let's see this in action. Going into the configure section of the parent job. We update the script and now we have 2 build jobs. We have yet to create the second build job. We have set the quiet period to 5 seconds and set wait to true for both jobs. Let's save the job and go into child job 1, where we make child job 1 to sleep for 5 seconds. Let's save the job first. Now, let's create child job 2. Child job 2 is essentially the same as child job 1, but it's just that the echo text is printing out child job 2. Let's save and build the child job 2 to initialize it first. It will end with an error, but that's okay. Refreshing the page. Take note that the Build Now link is now built with parameters. Okay, so let's start the parent job. Now, you can see that child job 1 has kicked off, but there is no new child job 2 build yet. Once child job 1 has finished, child job 2 kicks off. You can see that there is a new build for child job 1, and also a new build for child job 2. Now, let's set the wait parameter to false to see what happens. Saving the parent job. And kicking off the build. We now see both child job 1 and 2 are scheduled at about the same time, but the parent job does not wait for them to finish before completing successfully. You can see that there is a new build for child job 1, and also a new build for child job 2. I hope you find this useful. Let's move on to the next lecture. In this lecture, we take a look at the Lockable Resources plugin, which will let us do resource locking amongst competing builds. Resource locking does not mean we are actually locking up the real resource. It's a logical resource that we define in Jenkins that represents the actual resource which is used by the build. Examples being printers, computers, etc. Before we create any build jobs, let's go into Manage Jenkins. Configure System. Lockable Resources Manager. Here, to define a resource, we give it a name. Description field, as the name suggests, allows you to describe your resource. Labels are meant to group resources together. One or more resources can have the same label, which will allow us to lock groups of resources using a single label. We shall take a look at that later. Reserved by text field is used for locking up a resource so that no other builds will have access to it until the text field is clear. We shall also take a look at that later. Let's create a single resource, creatively called Resource 1. We now save the resource and let's take a look at a single resource locking example. Creating the first job. With the first job, we lock resource 1 and then print an echo statement out to the console and sleep for 5 seconds. We wrap the entire script in a timestamps block so that we can see the timings of what is printed out on the console. saving the first job and creating the second job. With the second job, it's essentially the same as the first job but without the sleep step. Let's save the job. Now what we are going to do is to kick off job 1 followed by job 2. So going by job 1 console, we see that it has locked up resource 1 and gone to sleep. Going over to job 2, see that job 2 is waiting for resource 1 and finally managing to lock onto it after job 1 has released it. When job 1 has finished releasing resource 1 at time 14:53 and 52 seconds, job 2 managed to lock onto it at the same time. Now, let's take a look at how we can lock resources by labels. Let's create a second and third resource. We label resource 2 and resource 3 under the same label, resources 2 3. Now, let's save the lockable resources configuration. We now create a job that will lock up resource 2. And that it also sleeps for 5 seconds. And we now create another job that will want to lock up resources 2 3. Note the use of the label parameter in the lock step. We have specified all resources that have the label resources 2 3 to be locked before proceeding. Please also note that you can use only either the label or resource parameter but not both. Let's now save the job. So in summary, what we have now is a job that will lock up resource 2 and sleeps for 5 seconds and another job that wants to lock up resource 2 and resource 3. Let's run lock step resource 2. And now we run lockstep resources 2-3 build job. Looking at the console of Lockstep Resource 2 build job, we see that Resource 2 has been locked up and Lockstep Resources 2-3 build job has managed to secure a Resource 3 but waiting for Resource 2 to be made available, going by the correct amount number which is 2. Now Resource 2 is released at time 14:58 and 8 seconds. And Lockstep Resources 2-3 build job has secured Resource 2 at time 14:58 and 8 seconds, and executes the downstream code. Now, we want to demonstrate how to use the quantity parameter that is used together with the label parameter where we can specify the minimum number of resources to lock before executing downstream code. Going back to Lockstep Resources 2-3 build job. We now specify the quantity of the lock step to be 1, which will require the lock step to lock onto Resource 2 or Resource 3. Let's now run Lockstep Resource 2 build job. And now we run Lockstep Resources 2-3 build job. As you can see, Lockstep Resources 2-3 build job only needs to lock one resource, which in this case is Resource 3, before executing downstream code. Now let's take a look at the inverse precedence parameter. By default this parameter is false, which means that builds will be given the locks in the order they requested. Let's see this in action. We will be creating another build job Lockstep Resource 1C that will compete to lock up Resource 1 and then sleep for 5 seconds. We will now update Lockstep Resource 1B build job with the same pipeline script. Lockstep Resource 1A pipeline script is already the same as Lockstep Resource 1C pipeline script. To demonstrate how inverse precedence equals to false works, we will triggering of Lockstep Resource 1A build job, followed by Lockstep Resource 1B and Lockstep Resource 1C build jobs. From the console, you can see that Lockstep Resource 1A build job has acquired Resource 1 first at 16:06 and 59 seconds, released the lock at 16:07 and 4 seconds, at which time Lockstep Resource 1B build job locks onto it. Released it at 16:07 and 9 seconds, and then the Lockstep Resource 1C build job locks onto it. Now, let's set the inverse precedence to be true in Lockstep Resource 1A build job. Triggering all three build jobs in the same order again. Lockstep Resource 1A build job acquires the lock first, released it at 16:09 and 5 seconds, but lock on Resource 1 was not acquired by Lockstep Resource 1B build job but by Lockstep Resource 1C build job, because inverse precedence parameter is set to true, which means that newest build to request a lock will be granted it first. After Lockstep Resource 1C build job releases the lock at 16:09 and 10 seconds, then Lockstep Resource 1B build job gets the lock. Another thing that I want to show you is the lockable resources link here. Clicking it will show you what resource is locked by whom. We will also make use of this screen when we demonstrate how the reserved by text field works. Going back into Manage Jenkins, Configure System. We now want to reserve Resource 1 by putting in some text in Reserved by Text field. It can be any text, but it should be meaningful. Let's put John in here. So once we save it, we go back to the Lockable Resources dashboard and we see it has been reserved by Jean, so all other builds will not have access to it until the reserve is released. Let's now kick off Lockstep Resource 1A, and Lockstep Resource 1B. You can see from the console that the two builds are waiting for resource 1 to be released. Going back to the lockable resources dashboard, let's now unreserve resource 1 using the Unreserve button. And you can see that resource 1 is immediately taken by lockstep resource 1A, build 4. And waiting for a while longer, we see that lockstep resource 1B, build 4, has locked up resource 1. I hope you find this useful. Let's move on to the next lecture. In this lecture, we look at how we can create a multi-select checkbox as an input parameter to the build, just like how it is shown here, where we can select multiple options and assign it to a single variable. Take note that this is unlike the choice parameter that we have covered in previous lectures, where we can only choose one option. As a demonstration, let's do a build. We have already selected some arbitrary options, and let's click on the build button. Going to the console, we see that the options that we have selected is printed out. We did not print out the values of the single choice parameter, as they are not the focus of this lecture. This multi-select functionality is provided by the Extended Choice Parameter plugin. Going into Manage Jenkins, Plugin Manager. We see that we already have the Extended Choice Parameter plugin installed. Let's create a new job to see how we can create this multi-select parameter. With this example, we are using scripted pipeline. Now, before we go any further, let me just show you the GitHub page of the Extended Choice Parameter plugin. In my opinion, the documentation of the Extended Choice Parameter plugin could be better, so we need to take a look at the source code of the plugin to see how we can create this multi-select parameter. Looking at the Extended Choice Parameter definition Java file, one of the things that I want to point out to you is that the Extended Choice Parameter plugin does not only create multi-select option. Looking at the constants of the Java file, we can see that we have the option of creating other types of options like single select option, checkboxes, radio boxes, etc. We will be referencing this Extended Choice Parameter definition Java file as we walk through what is going on in the pipeline script. Going back to the pipeline script, let's examine line by line what is happening here. So the first line is an import of the Extended Choice Parameter definition class. It is the class we saw just now. In the Node section, we create a new instance of the Extended Choice Parameter definition class inside the Properties step. As you can see, there are many constructor arguments, so we will go back again to the Java file and we search for public Extended Choice Parameter definition. You can see what the constructor arguments are. We will be switching back and forth between the pipeline script and this Java source code to see how the constructor arguments are mapped. So the first argument is name, and we have color of car as the name of the multi-select option. We have typeset as PT checkbox. That is the name of the constant at the top of the Java file. Next, we have value as the third argument. We have set a comma-separated string of values, red, blue, yellow and green. We leave the subsequent arguments as empty strings for now as we are not using them. And we go all the way down to description property value where we set the description of the multi-select values that we specified above, which are red, blue, yellow, green. This is what's going to appear to the user. We have set the save.json parameter to file and quote value to false as we do not need them. We have set visible item count to 4 so that we will not have a scroll bar beside the multi-select box. If our number of options is big, then visible item count set to 4 will show to the user only 4 items at a time with the scroll bar at the side for the user to view the other options. The description argument allows us to write a short description of what this multi-select option is about. And the multi-select delimiter argument allows us to specify what the delimiter is for the property values. In this case, we have set it to a dash so that the values of the options that we have selected will be delimited by this dash. At the end of the script, we print out what the user has selected. Note that the variable name we are using is the same as the name we have specified in the first parameter to the constructor. Let's save and run the job. As per previous lectures on parameters, we will always need to run the build once to initialize it. After that, we refresh the build page and we see that we have the build with parameters link. We click on that and we see that the multi-select option is available to us. We select 2 options and click on the build button. Going into the console, you can see that the values of the options we selected is being printed out and they are delimited by the delimiter we specified earlier, which is a dash. Going back into configure, you can see that we have additional sections here in the build job that have been created with the values that we have specified as constructor arguments to the extended choice parameter definition class in our pipeline script. Feel free to explore the other options that extended choice parameter definition gives you. Please let me know if you want me to do more lectures on this plugin. I hope you find this useful. Let's move on to the